So this is the question we want to solve. 13 is equals to 4 raised to power s plus 2s. The question looks like it's almost impossible to solve, but we can actually solve it. So now the method I will use here is called Lambert's W function. So like this, or gamma function. So now the definition for Lambert is Ws equals s e raised to power s. So where the W is the product log W function. So the definition is s e raised to power s. So my aim in solving all this equation is to change this equation we have to the form of s e raised to power s. So you will understand the s e raised to power s as I continue. So now this equation I can write it as 4 raised to power s plus 2s is equals to 13. So instead of saying 13 is equals to, so I can say all this expression is equals to 13. So it's allowed. So now this is the same thing as 4 raised to power s equals 13 minus 2s. So I want to remove this 2 at the back of s out, like say it's common. So that will be 4 raised to power s to 2 brackets. Remember, anytime you say something is common, like I said 2 is common now, I have to divide everything by 2. So that will be 13 over 2 minus 2s over 2. So this is 4 raised to power s is equals to 2 into 13 over 2 minus x. Remember, 2 will cancel out 2 there. So I can divide both sides by 2. So divide both sides by 2. So this will become 4 raised to power x divided by 2 equals 13 over 2 minus x, like that. So now if you look at what I have here, so how can we achieve our aim in this case? So now to achieve your aim, so you have to make all this s to be in one side, all the s. So now let me put this in bracket. So this expression you have here is the same thing as this is 1 over 2 equals 1 over 4 raised to power s. Now look at this. Do you know if I cross multiply here, this is going back to this place, as in just look at it. If I cross multiply, that means what I do there is still normal. So bracket 13 over 2 minus s. So I'm bringing this 4 here, but it will be 1 over, so that if I cross multiply, then it's going back to this place. So that is the an approach there. So now this is the same thing as, or in another way that you should understand this part so that you will not cram, I can say multiply both sides by 1 over 4s, so that this will become 4 raised to power s over 2 times 1 over 4 raised to power s is equals 1 over 4 raised to power s times 13 over 2 minus s. So I'm multiplying both sides by 1 over 4 raised to power s. So 4 raised to power s will cancel out. So I will now have 1 over 2 equals 1 over 4 raised to power s bracket 13 over 2 minus x. So you can get it this way. So now I have to multiply both sides now by before, let me cancel this place so you can have space. So from here, so I can say this is the same thing as 1 over 2 equals 4 raised to power minus x. This 1 over 4 raised to power s is 4 raised to power minus s. 13 over 2 minus x. So let me move it here. So 4 raised to power minus s brackets 13 over 2 minus x, so it's equals to 1 over 2. So instead of writing 1 over 2, I just move it here. So I did not change anything there, just turn it. So now my aim is to make it what I have here should be at this power. So how can I achieve that now? So now multiply both sides by both sides by 4 raised to power, because I have this, that will be 4 raised to power 13 over 2. So I'm multiplying both sides by 4 raised to power 13 over 2. So this will becomes 4 raised to power minus s times 4 raised to power 13 over 2. So you can picture why I multiply by 13 over 2, 4 raised to power 13 over 2. Now I want to achieve this. So multiply both sides by 13 and 4 raised to power 13 over 2 minus x is equals to 1 over 2 times 4 raised to power 13 over 2. So using this is here, remember the base are the same, you are going to add the power. So this is 4 raised to power 13 over 2 minus s. Remember, take 1 then add the power. So do you see the power under x now is 13 over 2 minus s, which is what I have here. So you will see where I'm heading to now. So this is 13 over 2 minus x is equals to 1 over 2 times 4 raised to power 13 over 2. So what I have next is I have to use exponents now. What is the exponent? Take note that if I have e raised to power ln s is equals to s, as in e raised to power ln s is equals to s. How is it like that? So note that ln s ln s is equals to log s to base e. So if I put it here, this will be e raised to power log s to base e. So according to this law, a raised to power log s base a is equals to s. So this and this are alike, the result is s. Watch my video on logarithm. We have proved that law in logarithm, so we have shown that. So now that is part of law of logarithm, so we'll prove it also. So here now I can say this is so I can say this is 4 raised to power 13/2 minus x e raised to power ln 13/2 minus s. So this e raised to power ln 13/2 minus s is the same thing as ordinary 13/2 minus s, like I showed just now. So this is 1/2 times 4 raised to power 13/2. So like that. So the next thing is likewise this 4. This 4 here. If I apply the lane on this one, I may not really achieve what I want. So let me apply the lane. So let me apply the lane on this one. So that will be e raised to power ln 4 raised to power 13/2 minus x times 13/2 minus s is equals to 1/2 times 4 raised to power 13/2. So this power can go to the back. Remember law of logarithm. Log a raised to power n is n log a. So this will becomes, as in this will be n log a. So this will becomes 13/2 minus s. E raised to power 13/2 minus s ln 4. So times 13/2 minus s. So meaning this one we just go to the back of the ln, then is equals to 1/2 times 4 raised to power 13/2. So this is the same thing as 13/2 minus s e raised to power 13/2 minus s ln 4 is equals to 1/2 times 4 raised to power 13/2. Now look at the power on e here. I have to get another ln 4 here. Remember, my aim from beginning is to achieve s e raised to power s. So if I achieve that, so I'll get my answer. Now multiply both sides by ln 4. So this will becomes 13/2 minus s ln 4 e raised to power so 13/2 minus s ln 4 e raised to power 13/2 minus s ln 4 is equals to 1/2 times 4 raised to power 13/2. Now look at this expression here. I've achieved my aim. So look at the expression here. I have the same number here. So that is, this is now like s e raised to power s, meaning the term I have here is what I also have here. So I've achieved it. So far I've achieved that so I can now proceed. So I'll get my answer like that. So let me move this. So now from here, and we already know that I'm multiplying both sides by ln 4, so that's why I brought this one up. So let me manage it here. So everything is equals to what do I have here before? Half times 4 raised to power 13 over 2. Half times 4 raised to power 13 over 2 times ln 4. Remember, I'm multiplying both sides by ln 4. So that's it. So now, according to our definition, so Lambert's function is f of s is equals to s e raised to power s. So f of s is what? S e raised to power s. Take note. So now that means as I have 13 over 2 ln 4, e raised to power 13 over 2 ln 4. That is the same thing as f of 13 over 2 minus s ln 4. So f of 13 over 2 minus s ln 4 is this e raised to power this. So just like f of s is equals to s e raised to power s. Take note. So it's equals to 1 over 2 times 4 raised to power 13 over 2 times ln 4. So take the product log of both sides. Take the product log of both sides. So to take the product log of both sides, then w is the product log. So let me say, just like you said, take the logarithm of both sides in your work. So take the product log w of both sides. So that is w f 13 over 2 minus s ln 4 is equals to w 1 over 2 times 4 raised to power 13 over 2 times ln 4. So you take the product log of both sides. That product log is w. So now w and f are inverse of each other, so it will cancel out. So I will have 13 over 2 minus s ln 4 is equals to w 1 over 2 times 4 raised to power 13 over 2 times ln 4, like that. So now what I will have left is this w. How can we take care of that w? So we can press calculator to get the w. So the w is in your calculator. Take note. So this is your scientific calculator. You can press it also. So this will becomes what is now w this, but let me get those number in decimal first, as in 1 over 2 times. So press your calculator. 1 over 2 times 4 raised to power 13 over 2, 4 raised to power 13 over 2 times ln 4. So 1 over 2 times 4 raised to power 13 over 2 times ln 4. So that is 5, 6, 7, 8.262. So let me approximate that way. So in your calculator, you can also press the W. You can do that in your scientific calculator also. Casio, example, Casio calculator, you can use it. So now this is the same thing as trying to press the W, but this is 13. Remember, this is 13 over 2 minus s will be equals to W 5678.262 divided by ln 4. So that is, take this ln 4 under. So I have 13 over 2 is what? That is 6.5. So this is 6.5 minus s is equals to, now what is W? Just like you are pressing log in your calculator, like log 2, log 3, that is how you can press W 567 also, because it's a function. So let me press 5678.262. So that is 6.7368. Let me get more digits. So that was 6.73681344 divided by, so ln 4. So ln 4, you have ln in your calculator also, that is 1.38629436112 anyhow. So you can still approximate, but I want the answer to be at least more exact. So now divide. So we have 6.73681344. 6.73681344 divided by 1.386 294,36112. So that is 4.85958. Collect like terms. So s is equals to 6.5 minus 4.85958. So s is equals to 6.5 minus 4.85958. So that is 1.64042 approximately. So this is approximately the answer. so we can confirm the answer, maybe it's right or wrong. So you can check if you are right or wrong. So this is our answer now. So this is the answer. So check. 13 is equals to 4 raised to power s plus 2s. So 13 is equals to, remember the answer is an approximate answer. So anything I will get here too should be approximately equals to, because if it is not approximately equals to, then something is wrong. So 4 raised to power 1.64042. So that is 9.7192 plus 2 times 1.64042. So that is 3.28084. So 13 is equals to, so add 9.7192 plus 3 plus 3.28084. So that is 13.00004, and you can see that is approximately 13. So that means the answer is correct. So for so we have shown now that for 13 is equals to 4 raised to power s plus 2s. We have shown that s is equals to, so that is s is approximately equals to 1.64042. Done.